So after you've made your video with your air disk, you now need to use the graphical analysis, the video physics, to generate the data for your graphical analysis so it can make the position versus time graph. So the first thing you're supposed to do after you've made your video is to set your reference scale. My reference scale is going to go from this mark, tape mark, to this tape mark. I want to click on the arrow going from side to side, and my scale is now 1 meter. You can change that to anything you want, but the easy thing to do is to always make it 1 meter. Now you notice I could actually set my scale anywhere. My disc does not have to go across the scale. So you could actually set your scale way up here and you would be fine. So what you want to do is you move your circle with the crosshairs and you put it right in the middle. Now I can see the crack of this floor. I'm going to try to line up my crosshairs on the crack, and I'm going to put it right there, and you click. Now you have a dot. So I move my crosshairs to the other side. I try to line up my crosshairs on that crack so it'll be straight across, and I click my dot. The more accurate you are, the better your data will be. As we pointed out before, you don't want to be shooting your video at an angle or it will be deceptive. You want this distance to go straight across and be parallel with how you set up your video. So that's how you set your reference scale. Now we want to set our XY axis. That's where you click on the XY, and you can move this, your 0 point right there. If you take your 2 fingers, you can turn it around. Okay, so if you do get a video, like for example, if I was videotaping something going down this board, I can set up my axis to where it measures the distance going right down that board. But in this case, I was straight across, so I'm going to try to line this up right with the crack. And then we're good. Just to double check that, I'm going to click back on my white line. You see my X and Y axis line up perfectly with my reference line. So now I've set my reference scale and I've set my XY axis. Now we go back to the first point where you have the little crosshairs with the dot in the middle, and now I'm going to generate my data points. Now you can use your finger. My fingers don't work as good. I'm old. So I bring my disc into view. Now you can start anywhere you want. It doesn't matter. Like you start right at the beginning, but it doesn't really matter. So you move your crosshairs. You pick one point that you can keep track of. So I'm going to pick the black dot right on the middle. It does not matter what point you pick. Now you can let up off of it and then click, and it puts a blue dot there. So you now have a data point. Then you move your crosshairs and you try to get the exact same point on the device every time, and I click. Now you'll find you can go faster. I'll try to do it with my fingers like you'll have to do, unless you have a stylus. And you can hold it and click and use 2 fingers at once, and you can go pretty fast. Let's say I decide I want to change everything, and I realize, I really would have liked to have all my points lined up on my green line. So you can go back, use your controls down here. I can go back one, I get a yellow dot. Okay, I can now hold on that yellow dot, and I can either delete one dot or I can select all, and I can delete all of them. So now I've decided I'm going to keep my cursor lined up on the green line, and I'll just center it on my circle so I really know what my horizontal velocity is. So I click once, twice, 3 times, 4 times. Now I'm not paying attention, somebody says something funny and I go up here and I keep going. And all of a sudden I realize I have made a huge mistake. You do not have to start all over. Just go back one step at a time. It will turn every dot yellow. When you get to your bad dot, click and hold it. Just delete that dot, and then you can move your crosshairs back and do it correctly. And then to get the rest of the dots, you just go forward. Okay, I'm just going to use your instructions. You'll need to do 10 dots, and they should all be lined up in a row. Then I want to use this information to generate a graph in graphical analysis. So I click on my little send the data somewhere, and I want to open data in, and at least on this one it only has one option, but the one we want is graphical analysis. And it'll open up both graphs. We are only interested in our XY, so let's go to, by the way, you can see all your data in a table form, which we'll look at in a minute. This video did not have any movement in the Y direction, so I only want one graph. I click over on this the Y axis, and now I get to choose what I want to look at. I want to look at the X versus time. So I get rid of my X velocity, my Y velocity. I have time down here, and I click back on my Y axis, and that goes away, and this thing never have liked it. So now I have, this is what we expect. We know from our previous unit that if you have constant velocity, you should get a straight line in your X position versus time graph, or X versus T. So I highlight that, and this we all know how to do. I go to linear, and I add that, and this tells me that my velocity was 1.506, right? Because the slope of this line gives me the velocity. So let's see how that compares. Let's go back and let's put our y-axis, or x velocity on there. Now my red one says that my y-intercept is 1.743, which is pretty accurate. Now, the problem is that my time is 9 seconds. I've done this before and gotten where my y-intercept is really off. That's because if you're just slightly got a slight angle here, by the time it goes all the way back to 0, any error in your slope, if the slope's supposed to be 0, any slope at all is going to give you an error. So the better way to compare that is to go to the table, and you can see that your x velocity is 1.47, 1.49. It's right at 1.5. It bounces back and forth before that. So from this data, it's pretty clear that our 1.5 is really, that the 1.7 y-intercept doesn't really help us. So we can see that our slope that we generated is, all these numbers are right around 1.5. So if I go back to my graph, this 1.5, that slope really is very accurate as to what the velocity is. So every student should do this. And again, you can, if I close this, I go back to my graphical analysis, my video physics, sorry. Then if I want to get rid of those so my next student can do it, I go back. Maybe I don't. There we go. So I get a yellow dot, hold it, select all, I delete them, and the next student, you actually could, you don't have to hit every dot. I could choose one here, line it up, and click the screen. Then I can move it forward. I could skip some spots, and since this is constant velocity, I should get the same answer. But everybody should practice a little bit the technique of hitting and with 2 fingers, or in this case a stylus and a finger. So as soon as you've done your equation, show me the data real quick. Won't take very long. We need to go ahead and finish this up and get on to the next activity.